Hello, in this video we'll be showing you how to use the code that is shown on the screen to actually compress a JPEG image, a JPEG format. So it reduces the size of your JPEG. The first line, okay, initially, yeah, the image, we already set the directory, so that the particular directory where your former image, where your initial image is, that's where it's going to actually save your final image. The first line is just to clear the screen. This image variable in line 2, we use the imRead function. It actually reads the image, so it reads it into the variable image. So our initial image is stored in the variable image. Size DRL is a function in MATLAB. DR is a function in MATLAB which actually stores different information about the particular image, like the bytes, that's the storage, the timestamp, duration, date, blah blah blah. You can always print that out to actually test it. The size dir is the variable where we should store it into. So since the size dir has a particular property, bytes, we now access that particular property divided by 1024, and we assign to a variable size image. Here, this you can now use a print statement in line 5 to just actually print the initial size, which we will show later on. And then the im show image, it just actually shows us the initial image, where the image was initially. I'll go to the next section. The first line, that's line 11, I is equal to image. The image, that's the image in section 1, that is the variable that contains our initial image. Here we now index the first channels. Every image has three channels. That's the red, the green, and the blue. The green will be indexed set 2, and the blue will be indexed 3. So the first image, the first channel, which is in the red channel, we index with 1. The second line, line 12, I equals to im2 double. Im2 double is just a function in MATLAB which converts the image to the image to a double precision format. This is necessary for DCT processing. Now DCT processing, which in the next line, it's the next line DCT, the next line just creates an 8 by 8 DCT transformation matrix T. Now the next line, b equals to blk proc, with the parameters taken in, it just basically applies the DCT to the image in 8 by 8 blocks using the transformation matrices T and its T transpose and its transpose T apostrophe. Mask, we have to basically mask an image we want to compress. Mask, this line is just defines a binary mask that will be used for quantization. The mask is applied to the DCT coefficients to actually achieve compression. The B2, we use the BLK proc again, takes in the particular variables, but this time with the mask variable in it. And then the last line, that's line 24 in this section, image 2, apply the BLK proc function again. It applies the inverse of the DCT to the quantized coefficient. The quantized coefficient is the B2, using the transpose of the DCT matrix T prime and its original T. This step just basically helps us to reconstruct the compressed image for the first channel. We do this for the second channel. Like I said, the second channel will be indexed 2, which you can see here, and then the third channel, we do is exactly the same process. The third channel we index 3. So after we do that for the first channel, second channel, and third channel, we just have a last section. So this last section, that's in line 58. MATLAB has a particular function cat, which is just for concatenating. That's just adding different parts. So just basically add what we've achieved in the first channel, that's in the second section, the third section, and the fourth section. That's, we have the image 4, we index it, we will concatenate it to the image 3, concatenate to the image 2, which we already did before. We now save everything to a variable add image. Then the im show is just to print. We would actually just see the image when we run the code. Now you see the image. So the im2 show just shows us how the image is going to be at the end. The im right, okay, now we are adding this particular add image. Now we are going to save it to a particular um the name of our final JPEG file. We named it compress. Then to just get the size, we just wanted to get the size, to just print it for clarification. So we'll see how the size of the JPEG has been compressed. So we save the final size is into the size final, which you said. I said the dir function inside MATLAB already has some properties. So just picking the byte property out, divide by 1024, and I'll have a print statement to just show this. Now I'll run the code for us to see how this works in total. Now initially I had the print statement. The print statement which says the original file of the original size of the image is this kilobytes. So you can see that the original size is the 408.162. Then we're waiting for the next we'll wait a little until it prints the final. So we're going to see how the image was initially and how the image is going to be final. You can see that there's almost no difference. The code we applied just almost does not almost take anything, does not reduce how it looks, but then the size of the JPEG has actually been compressed. We're waiting a little for the code to run to soon finish. So the final line here, the f print f, it prints the file. It prints. We're going to see the line that it prints. The compressed size of the image is this kilobyte. So we see that actually reduced it. We're waiting for the MATLAB to finish running the code, and then we can see that this has printed. Still waiting, and then yeah, we can see that this is now I wrote the AIM show image. Now this is the initial image. This is where the image was initially. I go down. Now this is the final way. You can see there is almost no difference in the two of them. This is the final way our image appears, and then at the end of the day you can see a print statement which we wrote here, which shows the compressed size of the image is this KB. So you can see this is the 113 KB. So you can see that it has gone from 408 KB, which is what is initially, to 113.93 kilobytes right now. You can see that the code has achieved its particular function. Thank you.